x minus 1 over x squared minus 1. So let's say we have this function. We're asked to find all vertical, horizontal asymptotes and their limits. Because if I say, oh, I know it has a horizontal asymptote y equals 15, it's not enough. I have to show that the limit of that function as x approaches infinity is 15. Okay? The same thing with a vertical asymptote. I cannot say that x equals 15 is a vertical asymptote if I don't show the limit from the left of 15 and the limit then from the right of 15. I have to show those. So just saying that this is a VA is not enough. I have to show these limits. Okay, so first of all, remember the key words. Factor, simplify. These are the key words. So of course what I'm going to do is right away do this. I will not touch the function before I write x does not equal 1 and x does not equal negative 1. Now I can touch the function and do whatever else I want to do, or just write here f of x equals 1 over x plus 1. Because the factor disappeared, this is a point. You don't have to call it anything, but 1 comma 1/2 is a whole. The factor that still stays in the denominator will create x equals negative 1 is a VA. But this is not enough. I have to find the limits left and right. So we're going to find them right now. So the limit as x approaches negative 1 from the left, and the limit as x approaches negative 1 from the right. And then here I will conclude again, that's why x equals negative 1 is a VA. And this, when x equals 1, because the factor disappeared, 1 comma, I cannot plug in 1 here. In the simplified form, 1 plus 1 is 2, and I get 1/2. And there will be, whenever I graph this function, you will have a hole. The hole will be at the point with x equals 1 and y equals 1/2. We're not graphing these yet. We will. So you don't have to graph. I'm just showing how it works. So now here, this should take a blink to determine, because I know that this is 1 over 0. All I have to do is plug in from the left of negative 1 and from the right of negative 1, and these should be answered in a blink. So, I guess it's more than a blink.
Did you write that the top is negative, the bottom is positive? Oh wait, sorry, backwards. Wait.
But what? What do I write?
Infinity and positive infinity?
Exactly. That's all I need. Excellent. So now, limit as x approaches infinity from 1 over x plus 1. Excellent. That's it. And it's done.
So you can say that 1/2 is a whole because it doesn't make the bottom 0. But when the bottom is 0, you have to make it, you have to do the from left and from the right.
Yes. Because the whole means that the function is like this. But the vertical asymptote requires to find what happens. Is it this? Is it this? Is it this? Is it this? I don't know. So for the vertical asymptote, I have to find the limits. For the whole, I already have it. It's 1, 1/2. Done. The limit from the left has to be 1/2. The limit from the right has to be 1/2. This is so-called removable discontinuity. Good. So then what do I get here?
Infinity?
D and E.
Would it be 0?
Thank you very much. When x approaches infinity, infinity plus 1 is infinity. If you have $1 and you want to share it with everyone on the planet, when you get to me and you knock on my door, you have nothing to give me. Which means that y equals 0 is a horizontal asymptote. Since this is a pure rational function, you do not have to check negative infinity. But if it's not a pure a rational function, you have to check what happens at negative infinity. But here there is no need. Good. Anything
So
else?
what will the function look like if you need to check x?
Ah,
Just negative infinity.
yes. So something like f of x is the square root of x to the fourth plus 1 over x squared minus 3. This is not a pure rational function. X approaches infinity and x approaches negative infinity will give different answers.
So when it comes to testing for horizontal asymptotes, you do infinity and or negative infinity, but vertical asymptotes, you have to
Yes, because you have several options. You have one option, you have the second option, you have the third option, and you have this. Oh, the other one. And you don't know which one it is. So I'm preparing you for the next chapter, in which that's what we did. That's what we have to do. So I have less work then. And you have less work by understanding already what needs to be done. Anything else? Are we working on anything else? Anything else once? Yes?
The problems where they want you to find the equation for a tangent line, and then they give you a point to work off of. That's like 2.8, I think. Let me see.
But all you have to do is just find f prime. So if I have 1 comma 2, I find f prime with the limit as age approaches 0 from the difference quotient, and then I plug in 1. So I have y minus 2 equals f prime of 1 times x minus 1. So once you find the derivative function, you plug in 1 and you get this number.
Okay.
Is that what you had in mind?
Yeah.
Yeah, that's it. So like we did here a few minutes ago with this function, you have to go through this process of finding the derivative. And if you're given, let's say, the point is 1 comma something, you plug in 1. So f prime of 1 would be 1 over 2 plus 2 squared. So that's 4. So 1 over 8, negative 1 over 8. And this is your slope. And the rest you use the point to find the equation of the tangent.
I remembered a question that I had.
Yes?
I'm a little confused on when you're supposed to be using the I think it was f of a plus x, then minus f of x, or the f of a minus x, like 2.7.
Okay, so you're talking about these two.
And sometimes you would do the thing that you just shown, the that helps you find the function of the slope.
So So f prime of a has two definitions, this or this.
Mhm.
F prime of x has only one, which we just used it a minute ago. So give me a function, and then we'll choose which one we want to work. You don't really have to use this. You can use this, and then at the end, plug it in. I meant x here, of course. Okay? So you can use this, and at the very end, plug in a. Or you can use one or the other. It doesn't matter. So which function you want to find f of a?
Is the last one, that's the definition of a derivative?
This is the only definition of the derivative.
Only definition. Okay,
Yes.
thank you.
This is the only one.
But like when they're asking for the slope of a tangent, can you use either of those lines, either of those problems?
If the function says to find f prime of x with a definition, you must use this. If they're asking you to find f prime of a, you can use this or this or this. I don't care.
So they have to specifically ask for f prime of a for you to use either of those other two.
Correct. But again, I'm happy if you use this, and at the end you say, I found f prime. Okay, now I'm going to plug in a, and this is it. I'm happy with that.
And then, so these are to find the tangent slope, and then to find the function, you do the y minus, and then equals.
To find the
slope.
equation of the tangent, yes. To find the equation of the tangent, you find y minus y, we use y minus y1 equals the slope times x minus x1.
So in general, is it just like a better idea to use f prime of a equals the limit as x approaches a when you're given a point?
It's a very good question. No, it doesn't matter. That's not connected to the point at all. It depends on the function. Sometimes this limit is easier to determine than this one. But this one may require more factoring than this one. So I can't give a recipe. I can't say for functions a, b, c, d, use this. For functions x, y, z, use this. I can't. It depends on the function. Do you want to work on an example? Okay, anything else? Other questions? Other questions? Okay, so we will have more study group, another study group before, at 6 o'clock on Thursday. If you have any questions, please bring them to the study group. Is that okay? Or do you want me to look at any problem one more time?
Wait,
Yes?
when's the test on Thursday? If the test starts at 6. When's study group?
The study group starts at 6, like always, and the test will start about 6:45 to set up.
Okay.
Anything?
Okay, thank you.
Thank you, sure. Anyone else? Any questions from anything? Okay, once, twice, 3 times. Of course, I'll stop if you remember in 5 minutes from now. If you remember something, please stop me. I'd like to start chapter 3. Well, in chapter 3, and you can use this to check. So this is okay on your scratch paper. Don't submit it because I can't give credit for it. So nothing in chapter 3 will be covered on test 1, but you can use what I'm going to teach you today to check your derivatives. That's fine. That is acceptable. Okay, let me start.